6.3 definite integrals and antiderivatives, worked out problems. So note the little disclaimer there. You got to try these without a calculator. I mean, the first one you can't really do with a calculator, but you should use your calculator to check your work if you don't feel confident as to what you're doing. We will do a test and a quiz without a calculator, so beware. I'm going to just run through these. This is put the -2 out front. Integral 1 to 9, f of x dx, -2 times, -1, 2. Calculator really wouldn't help you with any of these. This is integral from 7 to 9, f of x dx, plus integral 7 to 9, h of x dx equals 5 plus 4, 9. I'm gonna scroll down, move the page so you can't see up above here. You'll have to take my word for it. 2 integral 7 to 9 f of x dx minus 3 integral 7 to 9 f of x dx equals 2 times 5 minus 3 times 4 equals -2. This is equal to negative integral 1 to 9 f of x dx equals -1 is 1. 1 to 7, we're gonna get a little crazy here. We're gonna go 1 to 9 f of x I got it. F of x dx minus integral from 7 to 9 f of x dx. That's going to be -1 minus 5 is going to be -6. Over here, we're going to go integral, and I'll flip this one, 7 to 9 negative h of x minus plus integral, do that thing, 7 to 9 f of x dx. Put it there and I flipped it. When I put the negative, it becomes plus plus. Equals -4 plus 5 equals 1. Suppose that this is root 2, find each integral. So, sorry, -3 to 0, we want to go with -3 to 0. That's, of course, going to be -√2. This would be g of u du. Well, that's fine. That's the same as, that's just a dummy variable. A lot of people get hung up on that. That's the same as g of t dt, which we know equals √2. A lot of people freaked out, like, oh my God, it's a u. What do we do? There's no problem. tt, uu, xx, yy, doesn't matter. And this would be negative integral -3 to 0 g of t dt equals -√2. This would be 1 over √2 integral -3 to 0, and I'm changing this to gt. You could leave it, it doesn't really matter, which is √2 over √2, which is 1. Those h continuous and blah, 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 find each integral. So again, just more practice on this concept. This is going to be from -1 to 1, h of r dr minus, they want 1 to 3. That's as equals, I'm going to fix that, minus -1 to 3. Yeah, no, that's wrong. I wrote that in wrong. Thought so. -1 to 3 minus negative 1 to 1, h of r dr, which is 6 minus 0 equals 6. You might say, how can this equal 0? It's an integral. We've shown that before. The areas all over the place. So this equals from 1 to 3, h of r dr. To the left it is u, which is just wrong. Oh, well, just did it over here, 6. So I don't have to break it all out again. Neat. Show that f integral, blah, blah, blah. Here's an example. All right, so they're saying, what's going on if it's below the line? All right, some f of x here. So if f of x is below the x-axis, the integral is negative. All right, so give me an example. Fine. Integral from pi to 2 pi, sine of x dx, which is like this. I can do it by hand. Actually, I think I will do it by hand. Inverse antiderivative negative cosine of x, pi to 2 pi, negative cosine of 2 pi minus negative cosine of pi equals negative 1 plus cosine of pi, negative 1, negative 2. Moving forward, now we want to use that calculator. We don't have to. As a matter of fact, I will probably do it by hand. Then I'll also do it by calculator to check. Doing this average value thing. So we want to go with average value 1 over 3 minus 0 integral 0 to 3 negative x squared over 2 dx 1/3 negative x to the third over 6 0 to 3 1/3. Oh boy, negative 27 over 6. I'm ignoring the 0 because it's going to cancel out. Equals negative 9 over 6, negative 3/2. And negative 3/2 equals negative x squared over 2. X equals square root of 3. 2 out, cancel square root of square root. Don't need the negative 1, only the positive 1. So at what points on the interval? So root 3 comma root 3 squared is 3, negative 3/2. Let us see if that makes any sense. Math 9, 0 to 3, negative x squared over 2. Often forget this part, times 1 over 3 minus 0. Yes, I could have just written 1/3. Negative 1.5. Nice. Notice I have the extra work to do there to make sure I get it. All right. So here the average value equals 1/3. I'm already stopping writing little things that I used to write. X minus 1 squared dx equals 1/3. And I love leaving the 1/3 out front. It just makes my life easier. X minus 1 to the third over 3. And I'm going to pull that out as soon as I can. 0 to 3 equals 1/9. 3 minus 1, 2, 2 to the third. So I pulled the 3 out, is 8 times 8. Like I made a mistake in here. Oh, I'm not done, that's all. Minus, you have to plug in the 0. So quickly it gets out of your way from you. 0 minus 1 is -1 to the third, -1. So 1. So plug that in. 1 equals x minus 1 squared. Square root of both sides, plus or minus 1. Don't take the -1. Actually, we do have to do both and check. -1 equals x minus 1. X equals, add 1, 0. That's in the interval. 1 equals x minus 1. X equals 2. Looks like it happens twice, so it's a good thing I checked both those plus or minuses. So the first point is 0, comma, -1 squared 1, and 2, comma, 2 minus 1, 1 squared 1, 0, 1, and 2, 1. I'm not checking this with my calculator for the derivative, but I am going to graph this. Y equals clear. Value is 1. I'm going to put 1 down here. See if that makes sense. And then up here, it's x minus 1 squared. And let's graph. And I should have done a window, which I will. Window from 0 to 3. The graph's a little big. Let's go from -1 to 5. Okay. So that's the average value. It hits here and here. And if we summed up all of this area and divided by that, we'd get that red line. Neat. All right, find the average value without integrating, appealing to the geometry of the region. Sure, I'll get right on that. All right, 1 minus square root of 1 minus t squared. So that is, how the heck do I can do this, but how the heck do I explain this to somebody? Oh, let's just play with it. Plug in 0. 1 minus 1 is 0. Do this with this. Plug in 1. It's 1. Plug in square root of 2 over 2. No. I happen to know this is a circle. I would have graphed it on my calculator. So what's this area? Well, we're gonna have to go the whole box. So that's 2 times 1 minus the half circle that's missing. That's just brutal. Area, right, the whole box, 2 times 1 minus pi r squared, radius is 1 over 2 equals 2 minus pi over 2. Average value equals 1 over 1 minus -1. 2 minus pi over 2 equals 1 minus pi over 4. I'll leave it at that. You can also write it somewhere. Let's check out how we did. We'll just do the 2 minus pi over 2. So running a little out of space here. There we go. Math 9, from -1 to 1. And it's 1 minus second square root, 1 minus x squared. Remember, that's just a dummy variable. X. Complicated. Take its time. 2 minus pi divided by 2. Nice. All right. Now off we go. So where does it equal that average value? Well, that's so points of average. One minus pi over 4 has to equal 1 minus square root of 1 minus t squared. We can get rid of both these and these, and then we will square both sides. So we get 1 minus t squared equals pi squared over 16. Move that over there. So t equals plus or minus, move that, pull over, square root 1 minus pi squared over 16. That's crazy. That's crazy. So now we know the average value is actually 1 minus pi over 4. If we look up here, notice we found the -3/2 of the average value. That's where it hits on the y, duh. Average value is 1, that's where it hits on the y, duh. So knowing this, our 2 points are, is this in the interval? Yes, it is. Negative square root of 1 minus pi squared over 16, comma, 1 minus pi over 4. That's 1 point. And positive complicated stuff. All right, here we go. Tangent of theta. Negative pi over 4 to 4. Tangent of pi over 4 is 1, unless I'm very mistaken, which wouldn't be surprising if I was, but I think I got it. It does one of these kind of weird things. Average value is going to be 0. It's going to happen at 0, 0. So I'm not doing any math. I could go do this, but what's the point? Area equals 0. They cancel out. They're symmetrical. It's an odd function. Average value is 1 over pi over 4 minus negative pi over 4. What a waste of time. Times 0. 0. And point of average zero, 0. On a roll. By the way, you can always check those with Mint if you're feeling like you should. Problems 9 through 14, trip the integrand of rate of change quantity. Yeah, using the antiderivative. So here we go. Antiderivative of cosine is sine. Please be very careful doing this. Sine of x 0 to pi over 2. I'm going to start throwing out the wall on certain problems. I'm just going to go straight to sine of pi over 2 minus sine of 0. And the point I'm making is derivative sine is cosine. Always double check. Because people are like, oh, it's negative sine, because they got a cosine, it's negative. Yeah, always double check. Equals 1 minus 0 equals 1. This is going to be, like I said, I'm going to throw out the wall. Tangent of x. No, I'm not. 0 to pi over 4. Tangent of pi over 4 minus tangent of 0, which I would really be confused on, except we just did it. 1 minus 0 is 1. Interesting how these get to the same answer in their weird little trig worlds. Pretty cool. E to the x. I thought that was a constant there because it's a little fuzzy. So that is e to the first minus e to the 0 is e minus 1. And I just threw that out. X to the third over 3, 3's cancel. We just get x to the third. I was going to shortcut that. Boy, that's really a bad idea. So I'm not going to shortcut things anymore. Derivative 3x squared. Yeah. 2 to the third minus negative 1 to the third. Don't cancel those. They do cancel, but I would be careful. Minus negative 1. Now I'd cancel them. 9. Did we already do this problem? Sounds familiar. And then this. Holy cow. What are we going to do? I can't do this. It's impossible. Oh, wait. That's right. It's just arc sine. Where does sine equal 1/2? I'll write it out. Where does sine equal 1/2? Pi over 3? No, pi over 6. Pi over 6 minus what does sine equal 0? 0 equals pi over 6. Put that in the calculator and check if you're feeling like you don't know what just happened. This is ln of absolute value of x, 1 to e. These are all positive, so I can throw that out. ln of e minus ln of 1. Hey, that's 0. No, it's not. They cancel and leave 1. That's 0, 1. Which is pretty cool if you think about it. Find the average value of the function in the interval. You compute the interval. All right, average value. So I don't actually have to find where the point happens, though, so that's kind of nice. Average value equals 1 over 1 minus 0, integral 0 to 1, equals 1 over 1, goodbye, arc, tangent, x, 0 to 1, arc tangent of 1, where does tangent equal 1? Pi over 4 minus 0 equals pi over 4. Secant x, tangent x, average value equals 1 over pi over 3 minus 0, integral 0 to pi over 3, secant x tangent x dx. By the way, if you're wondering, yes, it hurts me to write that small. Equals 3 over pi, and I know this one. Isn't that just secant, or secant of secant tangent? Nice. Secant of x, 0 to pi over 3. 3 over pi. Secant of pi over 3. Nope, not going to do it. Cosine of pi over 3 minus 1 over cosine of 0. Notice how often we could get in trouble here with putting zeros on the bottom. So have to be very careful. In this case, we're fine. Cosine of pi over 3 is 1/2. So it's going to be 1 over 1/2 minus 1 over 1, which is 2 minus 1, which is 1, 3 over pi. Cool math. All right. Hope that helped. Good luck and happy mathing.